sp3d hybridization. In this hybridization, 1s orbital, 3p orbitals and 1d orbitals are intermixed, produces the 5 sp3d hybrid orbitals. It having 20% s character, 60% p character, 20% d character. For example, phosphorus pentachloride PCl5. In this, phosphorus is a central metal atom. Its atomic number is 15 and its electronic configuration in ground state is neon 3s2 3p3. It contains 5 valence electron in its outermost orbital. When phosphorus is excited, the one of the 3s orbital electron is promoted to the orbital of d, and these orbitals are intermixed and forms 5 sp3d hybrid orbital. These 5 sp3d hybrid orbital overlap with 5 chlorine atom to form 5 PCl sigma bonds, and the structure for the PCl5 is like this. The 3 chlorine atoms are present in one plane and 2 chlorine atoms are present in another plane. These are in equatorial position and these two are in axial position. The bond length of equatorial and axial positions are different, and the bond angle is here 120 degree and here is 90 degree. And this geometry is trigonal bipyramidal, and the magnetic property for PCl5 is diamagnetic in nature. Next one, dsp3 hybridization. In this hybridization, 1n-1d orbital, 1s orbital and 3p orbital are intermixed and form 5dsp3 hybrid orbitals. For example, pentacarbonyl iron complex. In this complex, iron is the central metal atom having atomic number 26. Its electronic configuration is 3d6 4s2, that is argon. In this complex, the oxidation state of iron is 0 because the carbonyl is a neutral ligand but strong field ligand. Because of strong field ligand, the electrons in orbital of 3d, they undergo pairing of electrons, and these pairing of electron results in the formation of vacant 5dsp3 hybrid orbital. These vacant 5dsp3 orbitals accept the 5 pair of electrons of carbonyl and forms 5 iron carbonyl bond. So this is the structure for pentacarbonyl iron, and its geometry is trigonal bipyramidal, and the bond angle is 90 degree and 120 degree. For axial 90 degree and for equatorial 120 degree, and the magnetic property of this complex is diamagnetic in nature. Next one, sp3d2 hybridization. In this hybridization, 1s orbital, 3p orbital and 2d orbital are intermixed and forms 6 sp3d2 hybrid orbital. It contains 16.6% of s character, 49.8% of p character, 33.2% of d character. For example, SF6 molecule. In this molecule, sulfur is the central atom its atomic number is 16 and electronic configuration become neon 3s2 3p4. When sulfur is excited, the electron in 3s2 and 3p4 orbitals are excited to 3d orbitals, and these orbitals are intermixed and form 6 sp3d2 hybrid orbital. These 6 sp3d2 hybrid orbital overlap with orbital of fluorine to form 6 sf sigma bonds. These having the geometry of octahedral with bond angle 90 degree, and the magnetic property is diamagnetic. In SF6 molecule, its hybridization is sp3d2, the geometry become octahedral, bond angle is 90 degree, and the magnetic property is diamagnetic. Next one, d2sp3 hybridization. In this, 2n-1 d orbital, 1s and 3p orbitals are intermixed and form 6 d2sp3 hybrid orbitals. For example, potassium ferrocyanide complex, or we can write like this. In this complex, the iron is the central metal atom having electronic configuration argon 3d6 4s2. Its atomic number is 26. Excited state of iron, the oxidation state of iron is +2. X plus 6 minus 1 equals to -4. We get x equals to -4 plus 6, that is equals to +2. The oxidation state of iron is +2. In +2 oxidation state, it loses 2 electron from 4s orbital. The cyanide ion is a strong field ligand. Because of this, these electrons in 3d orbital undergo pairing. When these electrons paired up and form vacant 2 3d orbital and 1 4d orbital and 3 4p orbital, they undergo intermixing and forms 6 empty d2sp3 hybrid orbital. These 6 empty d2sp3 hybrid orbital accept the 6 pair of electron from 6 cyanide ions and form the complex of octahedral with bond angle 90 degree. And here there is no unpaired electron. The complex is diamagnetic in nature. But in case of K3FeCN6 potassium ferricyanide, hybridization is d2sp3. The geometry is also octahedral. Bond angle is 90 degree, but the magnetic nature become paramagnetic. Determination of hybridization state. By applying this rule, we can calculate or we can identify the hybridization of any molecule, and this rule is not applicable for the coordination compound. The number of hybrid orbital is equals to half multiplied by total number of valence electron in central atom plus total number of monovalent atoms like hydrogen, fluorine, chlorine, bromine, minus of charge on cation. If the complex contain positive charge, we are applying the negative sign, and the plus charge on anion. If the molecule contain negative charge, we apply the positive sign. I will take one example, that is ammonium ion NH4+. In this molecule, The nitrogen is the central atom. It contains total 5 valence electron. When we apply this rule, number of hybrid orbital is equals to half multiplied by total valence electron plus monovalent ions are 4 and it contain positive charge, therefore we are applying the negative sign. One positive charge is present, that is 1, and the charge on anion, that is 0. We get 8 by 2, that is 4. Number of hybrid orbitals are 4, that means it is sp3 hybridized. And another example, CO3 2- carbonate ion. In carbonate ion, the carbon is central atom. Its electronic configuration is 1s2, 2s2, 2p2. That means it contains 4 valence electrons. When we apply the rule, half multiplied by 4 plus monovalent ions, here oxygen is present, that is 0, and the positive charge, here negative is present, therefore it is 0, and the next one negative charge is present, we are adding plus 2, we get 6 divided by 2, 3. 3 means it is sp2 hybridized. The carbonate ion is sp2 hybridized. Like this, we can identify the hybridization of any molecule. But in case of coordination complexes, we follow this method based upon type of ligand. For example, in pentacarbonyl iron, the carbonyl is a strong field ligand and its coordination number is 5 and the hybridization become dsp3. In case of cobalt complexes, its coordination number is 6. The ligand we are using is water molecule, weak field ligand, and the hybridization is sp3d2. In this way, we can able to identify the hybridization of any complexes. In next session, I am going to discuss about Bend's rule, resonance and energetics of hybridization. Thank you.